LeetCode 19. Remove nth node from end of list isn't just an interview staple, it's a real-world issue in disguise. Think about a stream where you need to drop the nth last packet, but can't count the entire stream first, or pruning the tail end of a log buffer without scanning it all. Waiting to tally everything is costly. That's why this problem matters, and why we're aiming to solve it in a single, clean pass. Let's kick things off with the classic brute force approach, the two-pass solution. It's simple, clear, and the perfect way to dip our toes in. First step, calculate the full length of the list. That'll tell us how far from the front we need to go to reach the node to remove. Once we know the length, subtract n to get the zero-based index of the node to delete, counting from the head. If that index is 0, we're deleting the head itself, so we just return the second node as the new head. Otherwise, reset the pointer to the head and walk it forward until we're right before the node we want to skip. Now that we're one step before the target, update the next pointer to jump over the node and unlink it. Wrap up by returning the updated head, which might be new or might be unchanged, depending on what we removed. This approach runs in big O of L time and O of 1 space. On a 10,000 node list, that's up to 20,000 steps across 2 passes. It's beginner-friendly but inefficient at scale. Be careful with head removals, and no need to worry about overflow. List size stays well within bounds. Let's step it up. The brute force method wastes a full pass just to count. We can dodge that by tracking a fixed gap between 2 pointers instead. To make edge cases easier, like deleting the head, we'll drop in a dummy node pointing to the list's actual head. Next, we anchor 2 pointers at the dummy. One will surge ahead by n+1 steps, creating the distance we need. We build that n gap by pushing the fast pointer forward n+1 times. When fast hits the end, slow will land just before the node we're removing. With the gap in place, we march both pointers forward together until fast hits null. That positions slow right before the node to skip. From here, just rewire slow's next pointer to bypass the target, and that node's gone. Wrap it up by returning dummy.next. That's our new head, whether or not it changed. This one-pass method keeps us at big O of L time and O of 1 space. For 10,000 nodes, it's around 10,000 operations, way tighter than the brute force version. It's the kind of clean, efficient move that shines in interviews. One sweep, constant space, and smart edge case handling. We started with a safe 2-pass, easy to follow, but inefficient. The 1-pass refactor is where things get clever. By holding a fixed gap and using a dummy node, we sidestep redundancy and remove the node in one streamlined go. It's more than a coding trick. It's a performance win. Whether you're working with network streams, memory blocks, or real-time logs, this pattern scales. And in interviews, it proves you think beyond just correctness. So here's a challenge. Where else could this 2-pointer trick shine? Keep coding. The next smart move is just 1 pointer away.